This huge structure connects not only 2 coasts, but also 3 giant cities. This mega project, which is exactly 55 kilometers long, is an incredible system of bridges, tunnels, and artificial islands. And the most incredible part? This giant bridge does not only cross over water. In a certain section, vehicles dive into a giant underwater tunnel and move under the ocean. The technology used in its construction is like something out of a science fiction movie. Giant piling machines place tens of meters long piers deep into the water. Then giant bridge blocks, each weighing tons, were placed in place with millimeter precision. Wind, waves, earthquakes. All of these were taken into account, and this bridge was designed to defy all kinds of natural events. When this process begins, giant machines start shaking the ground right before your eyes. Towering piling machines drive giant steel or concrete piles that are lowered into the ground with tons of weight or with huge vibrations. Each impact, each vibration creates giant foundations that are ready to support the skyscrapers, bridges, and megastructures of the future. And the most fascinating part, although the underground is not visible, this is where all the engineering marvels take place. Each pile is placed at the right angle and depth. In this way, the structures that will rise on it will stand tall for years without shaking or bending against all the forces of nature. As you watch, you will see the piles slowly disappear into the ground with the rhythmic impacts of the machine. At that moment, the invisible but strongest part of the structure is being built. When this machine starts working, giant piles weighing tons are driven into the ground as if there was no gravity. The vibratory driver generates high-frequency vibrations that instantly loosen the soil around the pile and slide the pile down almost by its own weight. No hammering, no explosions, just pure technology and a tremendous display of power. And the most incredible part? The process is both fast and incredibly controlled. The piles are placed in the exact spot with millimeter precision. The vibration and power generated by the giant motors are so impressive that when you watch them, you see the machines rippling the ground like water. Whether it's offshore platforms or giant bridge piers, when the pile cap's vibratory driver is on the scene, the foundation work is completed at the speed of light. It's a real game changer, not only with its power, but also by speeding up the entire workflow on site. Once this process begins, everything moves with speed, power, and incredible precision. Giant bridge assembly machines running on rails lift, transport, and place the massive bridge beams weighing tons in place without missing a beat. No need for heavy lift cranes or endless scaffolding. Everything slides along the rails, working in perfect harmony with each other. And the most fascinating part? With this system, bridge construction progresses like a pre-programmed robot show. The giant pieces move, align, and secure, all without stopping or pausing. Fast assembly, a small footprint, and incredible safety benefits are achieved. Thanks to this method, new bridges can be erected in just a few days, especially in areas where it is impossible to stop, such as railways or busy highways. When such a perfect harmony of technology and engineering comes to the field, time and costs simply evaporate. When this process begins, huge machines and vibrating saws are launched onto the site and begin to advance right before your eyes, right into the heart of the concrete. The heads of the piles weighing hundreds of tons are cut with special saws with great precision, as if by a giant sculptor. Dust clouds rise, sparks fly, and with each cutting stroke, the hard concrete breaks away piece by piece. And the most striking part, this process requires not only power, but also incredible precision, because only the surface excess must be removed, without damaging the bearing part of the piles. The operators cut with millimeter calculations. One mistake can jeopardize the integrity of the entire structure. That is why every movement, every stroke is carried out with the precision of a surgeon. Whether it is on the foundations of skyscrapers or the piers of bridges, when cutting the concrete head takes the stage, everyone watching is amazed by this perfect combination of power and finesse.
This huge structure challenges the imagination of scientists not only in China but around the world. This huge structure consists of 4,450 panels, and each weighs approximately 445 kilograms. So the total weight of these panels is more than a Boeing 747. Yes, you heard right. But what's really surprising is that these panels are placed with incredible precision. Each panel can be adjusted to an accuracy of 1/100th of a millimeter. And here is the most striking fact. Beipanjiang Bridge reduces the travel time between the two provinces from 5 hours to 1.5 hours. This greatly increases trade and tourism in the region and contributes significantly to economic growth. With this huge bridge, China reinforces its leading position in the world transportation infrastructure. Time will show us. The construction process of the new Southern Xinjiang Railway took 7 years and cost $2.8 billion. The dedication and skill shown by engineers and workers during construction is truly incredible. This huge project is 1,200 kilometers long and serves freight trains as well as high-speed trains. The engineering techniques and advanced technologies used in the construction process have attracted great admiration around the world. Huashinshan Hospital, built in Wuhan, China, during the COVID-19 epidemic that shook the world in 2020, is literally a miracle of engineering and logistics. This hospital was built in just 10 days and became a ray of hope for thousands of patients at the most critical moment of the epidemic. Yes, you heard right. This hospital was completed in just 10 days. The construction process of the Taishan nuclear power plant took 10 years and cost $20 billion. During this time, more than 30,000 workers and engineers took part in this huge project. Isn't it incredible? The engineering techniques used during the construction process of this huge project are a masterpiece. Advanced concrete technology and steel structures, especially used in the construction of reactor buildings, increase the safety and durability of the power plant. This bridge is one of the civil engineering marvels of not only China but the whole world. Danyang-Kunshan Grand Bridge, which is 164.8 kilometers long, holds the title of the longest bridge in the world. This bridge is part of the high-speed rail line between Shanghai and Nanjing and is truly an engineering miracle. First, let's take a look at the basic features of this huge structure. Fuzhou-Pingtan Bridge is 16.3 kilometers long and holds the title of being China's longest overseas bridge. This bridge will connect Fuzhou and Pingtan Island, radically changing the economic and social structure of the region. Do you know how this incredible dam was built? The construction process is an engineering marvel. Tens of thousands of workers brought this project to life, working day and night. 8 million cubic meters of concrete and huge turbines used in construction make this project truly gigantic. Additionally, special techniques were used when constructing the dam to ensure minimal damage to the environment. The Yellow River Tunnel is a huge tunnel that passes under China's Yellow River and is 7 kilometers long. This tunnel will connect two major cities, speeding up transportation and supporting economic growth. The Three Gorges Dam, built on the Yangtze River, is literally an engineering miracle. This dam, which is 2.3 kilometers long and 185 meters high, has the title of the world's largest hydroelectric power plant. Yes, you heard right. This huge structure is one of the largest energy production facilities in the world. The construction process of the Three Gorges Dam took 17 years and cost $30 billion. 40,000 workers were involved in the construction, and these workers poured 27 million cubic meters of concrete, each of which is huge. Is it difficult to visualize all this concrete? Think of it this way. With this amount of concrete, you could build approximately 63 Empire State Buildings. Daxing International Airport, located in the south of Beijing, is literally an engineering miracle. This huge airport attracts attention not only with its size, but also with its technological innovations. The airport has the title of the largest single terminal building in the world, with its terminal building spanning an area of 700,000 square meters. Yes, you heard right. This terminal building is approximately the size of 98 football fields. The construction process of the Hangzhou Bay Bridge took 9 years and cost $1.5 billion. 600,000 cubic meters of concrete and 800,000 tons of steel were used during construction. In such a large project, the dedication and talent shown by engineers and workers is truly incredible. The world's most advanced engineering techniques were used in the construction of the bridge, and this process aroused great admiration around the world. The engineering techniques used in the construction process are truly masterpieces. The double curvature surface technology, especially used in the construction of the building roof, gives the structure a unique aesthetic. Thanks to this technology, the roof is both lightweight and extremely durable. In addition, innovative ventilation systems used in the interior of the building offer a comfortable environment for visitors. The construction process of the Harbin Opera House took 4 years and cost $300 million. 27,000 tons of steel and 75,000 cubic meters of concrete were used during construction. In such a large project, the dedication and talent shown by engineers and workers is truly incredible. The building consists of 2 main structures spanning 79,000 square meters, a large auditorium and a smaller multi-purpose hall. Shenzhen Xinhai Development Zone covers an area of 15 square kilometers and aims to become one of China's most important finance, technology, and service centers. This region is rapidly progressing towards becoming the trade center of the future and is undergoing an incredible transformation. Today I will show you how oil is extracted from the depths of the sea. Yes, you heard right. You won't believe it until you see these huge oil platforms. Oil platforms are established to reach oil reserves meters below the sea. These platforms are equipped with oil drilling rigs, which drill holes in the seabed using huge drills. Oil is pumped from underground reserves to the surface. However, this process requires great precision and advanced technology. A cofferdam is a temporary structure used to isolate the work area from water when construction or maintenance work is carried out on underwater structures such as the sea or river. Cofferdams ensure that water stays out, creating a dry working environment inside. This allows engineers and workers to build or repair undersea structures safely and effectively. Hardanger Bridge is known as one of the longest suspension bridges in the world, rising in the magnificent nature of Norway. First, the bridge piers were placed. These piers were built on solid ground by excavating deep foundations below sea level. The cables were placed using huge pulleys and winches, and each was carefully tensioned. By carefully placing the decks on the cables, a big step was taken towards the completion of the bridge. Selva Tunnel is one of the important infrastructure projects built to speed up traffic and increase security. First, the ground preparation for the tunnel was made. At this stage, the floor is cleaned and a smooth surface is obtained. Asphalt paving machines work with high precision and lay asphalt smoothly. After the compaction process is completed, the asphalt surface is cooled and final checks are made. How are these huge pipes laid under the sea? Pipe-laying vessels transport large pipes across the sea surface and place them on the seabed. These vessels lay pipes with certain speed and precision. Pipes are connected to each other to form long lines. These connections are made underwater using special welding machines and techniques. This huge and complex structure has been successfully laid on the seabed thanks to advanced engineering and technology. This incredible process is truly awe-inspiring, isn't it? These huge structures convert wind energy into electrical energy. First, the area where the turbines will be installed is determined and preparations begin. A ground survey is carried out and a suitable foundation is created. The foundation is strengthened to support the enormous weight of the turbine. At this stage, concrete is poured and the foundation structure is created. The tower consists of steel or concrete panels and is transported in pieces and assembled at the construction site. After the assembly of the tower is completed, the rotor and blades of the turbine are placed. Finally, the turbine's control and monitoring systems are installed. Our next topic is port and pier construction. The foundation is formed by driving strong and durable piles under the sea. These piles are designed to carry the entire weight of the port and the pier. After the piles are driven, concrete and steel structures begin to be built. The port and piers are supported by large concrete blocks and steel beams. Once the skeleton is completed, the harbor surface begins to be created. At this stage, large concrete slabs are placed and asphalt is poured on top. Finally, the infrastructure systems in the port and pier are completed. Geothermal power plants produce electricity using hot water and steam underground. As a first step, drilling operations begin. After the drilling process is completed, hot water and steam are extracted from the wells. Installation of turbines and generators requires great precision. These components are carefully installed to ensure efficient operation of the power plant. Additionally, cooling systems must also be installed. These systems allow water to be cooled and pumped back underground after use. Here is the railway construction step by step. After the initial ground preparations are completed, a layer of gravel called ballast on which the rails will be laid is laid. After the sleepers are placed, the rails begin to be laid. The rails are mounted on the sleepers using special machines and tightly fixed with screws. Finally, tests and inspections of the railway line are carried out. First, the route of the Monaco Grand Prix is determined. After the road surface is prepared, barriers and fences are placed for race safety. Another important step is the preparation of the paddock area and pit stop areas. Teams build areas where they will prepare their vehicles and make pit stops during the race. These areas are equipped with high-tech equipment, and all details are considered to ensure that the race runs smoothly. Finally, the electronic systems and communication infrastructure of the track are installed. Floating bridges are bridges that can float on water and are usually used temporarily or permanently. These bridges are of great importance to ensure passage across lakes, rivers, and seas. And there you have it, a completed floating bridge. These magnificent structures make it possible to pass over water and constitute one of the best examples of engineering marvels. This advanced technology and engineering skills in the construction process is truly impressive, isn't it? This bridge was built to ease traffic and connect the two sides. During the foundation works, the piles that would carry the weight of the bridge were driven and the concrete foundations were poured. After the foundation works were completed, the piers and columns of the bridge began to be built. After the construction of the superstructure was completed, the asphalting and surface coating operations of the bridge were carried out.